Hey Mark, how you doing?
Oh, good. How you doing today, John?
Not bad. I'd like to talk about timing belts today. I've got two engines on a stand here that I'm going to talk about. You can see there's a little difference. This one is a single overhead cam. That one's a double overhead cam.
What happens when the belt fails?
Timing belts on vehicles today are a very critical service issue. And the reason they're such a critical issue is because they have to keep everything in the engine in time. And when I say that, what I mean is there's pistons moving up and down inside the engine, and there's valves that control the air and exhaust that move up and down as well. Well, if everything's not kept in proper time, the valves and the pistons can come together and touch each other, and when that happens, catastrophic engine damage. You have to tear the heads off, replace the engine possibly, because it'll be ruined. Now, you'll see here that the timing belt runs around the crank, has a tensioner, and around both of these camshafts here. Now, the camshafts move at half the speed of the crank. And everything's got to stay in perfect synchronization, and that's why we use the toothed timing belt. Now, when getting ready to do a job like this, one of the things that you must do is understand the whole procedure. And one of the best tools you can start out with is a good repair manual. Now, I have one here that's an excellent manual that we make. It shows basically every timing belt application that exists. It has lots of good illustrations. It will tell you all the repair procedures and steps, and even tools and components needed to do those jobs. So that's a great way to start any timing belt job, is with a good book. So what I've got here is just an example of an interference style engine.
What do you mean by interference?
Well, again, I was talking about that piston to valve touching each other. We call that an interference engine. Now, if this belt were to break, it's very likely we'd do damage to the pistons and the valves and have to do major engine repair. The other kind of engine that's out there is the non-interference type, or some people call it the freewheeling type. That means if the belt breaks, you can spin the camshafts around and the crank around and nothing will ever come into contact with each other. Now that's good if you break a belt, but it's not good for higher performance. Most of the higher performance engines are going to have interference styles, where even some of the ones today even have valve to valve interference. So that means that even if I were to take this belt off and I didn't keep everything solidly locked down, just by moving a camshaft or something, I could cause damage to the valves and cause bad engine damage there, and that wouldn't be good.
Is there a tool that we can lock those cams into place?
Actually, there is. We've got a couple different tools I'd like to show you. And this is for the single overhead style cams. And I've got another one I'll show you in a little while for the double overhead cams. This is called the Unilock tool. And the way this works is basically it clamps around one of the cam gears and fits into the tooth. And I can tighten it down so it's got a good solid grasp on that cam gear. Now, what I want to make sure is I have something behind it that I can clamp to. Now that that's set down, then I just screw this into the back of the engine. And that's going to keep that cam gear from moving when I take the belt off. Now, ideally, I'd be using two of these for this kind of an engine. For demonstration purposes, I'm only going to show you the one. Now, the way this belt is tensioned is we have a manual belt tensioner. Now, this greatly determines the type of service life I'm going to get out of this belt. There's manual and automatic styles. This one, the way it works is we just loosen it up, and then you can see I can move it back and forth to move the tension back and forth on the belt.
You can see there's a spring there, it's spring loaded.
Yeah, just a little bit spring loaded for initial tension purposes only. Once it's tightened down, the spring serves no function whatsoever.
Should we just replace the belt, or should we replace all the components of the drive?
You know, a lot of people will just take the belt off and replace the belt. Well, that's only doing half the job. I want to do the whole job. So what I want to make sure of is that all the components along with the belt are in good shape. So now that I've got that tension released there, I'm going to go ahead and pull this tensioner out. And I want to inspect that tensioner and make sure that it's turning freely, make sure there's no wobbling, anything like that. Now, this component's already lasted, say, 60,000 miles, 70,000 miles. Some intervals are even 90,000 miles. So if it's lasted that long already, and I want to be sure it's going to last to the next service interval, it's probably a good idea to replace this along with the belt. And we thought about that, and we made a timing belt component kit. And the way this works is it comes with the belt and the tensioner together.
I can see that.
Yeah, so we call it a TCK, timing belt component kit. It also comes with instructions that come with this kit to show you how to replace the belt on your particular application.
So in case you don't have the manual, you can just read those instructions.
You can read these instructions, and it just sources all the parts, makes it nice and easy to get it in one location. One-stop shopping. I'm getting ready to take the belt off, but before I do, I want to make sure that all my marks are lined up properly for my timing marks. One here on the crank, one here on both of the cams, and now that I've got them all lined up, I'm safe to take my belt off. So anyway, now that I got that off, I can take the belt off very easily here. And the one thing I want to be very critical about is before I decided to take this belt off, I lined up all my timing marks. Now, the timing marks can be seen on the cam gears. You can see one here, and you can see one that corresponds to on the back of the cover. You can also see one here, one that corresponds to back here. There's one down here on the crank and one that corresponds to on the side of the engine here. That means that everything's lined up in its proper position for service. Now, when it goes back together, it's very critical that everything lines up that way again before we start to turn the belt or any of the components again. I got the belt off. I'm going to go ahead and replace this tensioner. There's a little spring on the back. Remember I said for initial tensioning only? Tension can become pretty critical when you're looking at timing belt service. And I'll show you a couple different ways that we can address that. Okay, so I want to also make sure that none of my pulleys up here have any marks or cuts or grooves on them, because any cut or anything on a pulley at this point, crank gear, cam gear, or anywhere here, is going to damage my belt when it goes back on. One nick on a pulley will touch every single tooth on that belt. It will eventually cut through it just like a knife.
And catastrophic failure and you're stranded.
You'll have catastrophic failure and a big expensive repair bill. The other thing I want to look for is any signs of oil leaking out from these cam seals behind here. Also a good idea while you're in here to replace those seals if you have the opportunity to do so. On this one there'd be a seal on both cam sides and also behind the crank itself. Excellent time to replace those issues as well. Go ahead and put the belt back on. And what you'll notice here is the belt's also marked with marks up here, so that we can line those marks up with our timing marks. So there's absolutely no doubt on how this belt goes back together. Now, I have to back the tension off on this tensioner. Just kind of snug it down for the moment. Now, tension on this belt by the instructions shows that I have to try to tension this tensioner and then measure a part of deflection up here, a certain measurement that would ensure that I have the proper tension on the belt. Sometimes what a lot of technicians will do is they'll just use the thumb and finger method. They don't have the proper tool to tension the belt, they don't have the instructions, they'll just put it on and kind of feel it. Think, maybe it's okay, I think it's okay.
That doesn't seem very accurate.
It's not very accurate, and it's just asking for a comeback. It's asking for a problem. Because that vehicle's going to leave the shop and you're going to worry about it the rest of the time, whether you set the tension properly or not. And I'll show you some examples of belts later that are just terrible examples of what can happen if the belt's not properly tensioned.
Is there an easier way to tension the belt?
instead of measuring that, I'd like to show you a new tool that I have today that makes it very easy to set tension on a belt like this. Timing belt tension meter, tension gauge, and the way it works is it's got a spring inside. We've predetermined what this belt should be tensioned at the factory. And the way we compensate for different belts is with a thickness gauge. We take this thickness gauge and we put the smallest opening that will fit into. In this case, number 5 happens to be the smallest opening that this fits into. So I have to use spacer number 5 that's on this gauge. So it comes with several different spacers, and I screw the number 5 in here. There's 2 marks on this gauge, and up the top for new belts, brand new installation, down at the bottom, you don't ever want to be below that mark there. Fits on the belt just like this. You can read it from any angle.
Now, does it matter where on the span that you put the gauge?
I always like to put the gauge on the tension side of the belt. Wherever the tensioner is, or wherever the factory instructions recommend you check tension, I'd like to put it up there. So I could check it up here or down here. I always like to start out where the tensioner is itself. Now you can see, as I start to put tension on this, you can see it move back and forth.
You can see the gauge move right here.
Yeah. So right there is my perfect setting. So I'm going to go ahead and grab my wrench and tighten my tensioner. I'm going to take my gauge off. Now most people would stop right here, most technicians. I'm not done yet. I want to show you a tip that I've learned that really helps. Let me take off my locking device here. I'm going to move this timing belt around 3 revolutions to spread the tension over to the other parts of the belt, because I've essentially tensioned it here between the crank and the cam, and I've spread some tension over here, but I want to make sure I've spread it equally all the way around. So I'm just going to go ahead and move this around. There. It's just about to the point I want it. Now sometimes you get cam gears that are pretty peculiar about where they want to sit, especially when the belt's off. And you may have to use a little extra leverage to move them. This is just a cam sprocket tool. It's kind of like a spanner wrench, but it's adjustable and it fits real well in most of these types of drives. Let me show you how that works real quick. I can move that around and kind of fine adjust, get a fine adjustment on my belt. Make sure everything's lined up just right. Make sure all my marks line up. Now, I'm going to go back and double check that tension. We can see that it's still in good shape there with the tension. And we can see that if I put it up here, that we're still in good shape up here as well. So now this timing belt is in good shape, it's ready to go. I can start buttoning up the outside of the engine, put the timing covers back on.